Good afternoon, ladies and gentlemen. Good evening. Welcome to another series of tutorials with me, Aubrey. We continue with our series on revision questions. We are doing complex analysis. This is question number 6 that we're going to solve in this lesson. So basically, we're going to prove that if z is equals to a e to the I theta and a is less than 1, then this series converges to that. The answer for this series is that. So that is simply what we're going to do. So if z is equals to a e to the I theta, and a is less than 1, in this series, 1 plus a plus theta plus a squared, and so on and so forth, converges to us, or the sum of this one is equals to that. So basically, if you check on this side of the equation, we can find the general form of this series. That would be our first step, finding the general form of this series. Now, if you observe the pattern, we have 1, then a to the power 1, a to the power 2, a to the power 3, and so on and so forth, a to the power 4, and so on and so forth. So if this was 1, then a must have been raised to the power 0, so that a to the power 0 will be 1, then a to the power 1 will be a to the power 2 will be a squared, and so on and so forth. Same applies for cos theta. We see that we have cos 1 theta, cos 2 theta, cos 3 theta, and so on and so forth. So now for cos to be 1 here, had to be cos 0 theta. Now, if we can only get cos 0 theta if we had, or if we have n equals to 0. So simply, this writing in the general form can be given by this sum right here. The sum from 0 to infinity of a to the power n will be equal to that. When n is 0, we're going to have a to the power 0 plus 0, which is 1. When n is, let me just split out. When n is 1, we're going to have a to the 1, then cos theta, which is this cos theta. When n is 2, we're going to have a squared, which is this a squared cos 2 theta, and so on and so forth. So basically, this is what we have. This is equal to that. So we're going to show that this converges to that. But we've also been given an important information that z is equals to a e to the I theta, right? So we're going to start with this side of the equation, and we'll work it out until we get this here, right? So starting with the left-hand side, to start, the first thing that we would have to do is convert this into a z form. Okay? Converting it into z form, we don't want these thetas here, so we need to use these equations for us to convert this into z form. So what we know about cos theta in polar form is given by this formula right here. So this is the formula for cos theta. I think we've done a derivation for this formula, but you should know how to derive this formula. So cos theta is equals to e to the I theta plus e negative I theta all over 2. Now, if we have n there, so it means that cos n theta will be equals to e to the I, where there is theta, we have n theta minus I n theta. Meaning that this is the same thing as cos n theta is equals to that. So this can be replaced with that. This is what we're going to do. So replacing this with that, we get, and from here we're going to distribute the a times this, the a times that. And the other thing is that this 2 is applying both to this and this. So this can be written as e to the I n theta over 2 plus e to the negative I n theta all over 2. And we can distribute n like that, which will give us that. So this times this will give us that, this times this will give us that. And now from here, we need to find these in terms of z. Remember, we've been given that z is equals to this. So let me just center my bit. we've been told that z is equals to a e to the I theta. Right now, for us to have n a to the power n and e to the I n here, we need to introduce n both sides of the equation. We introduce both sides of the equation n. This will be z to the power n, and this can be distributed a to the power n e to the I n, yeah, which can be written as this. Right? Can be written as that. Can be written as that. So simply here, where there is a to the power n e I n theta, then replace with z. And we also need to work with this part. Now, on this part, we see that there is a to the power n and e to the I n theta, negative I n theta. So for us to find the replacement of negative I n theta, we introduce negative I on both sides of this n. So instead of just multiplying by power n, we assume we multiply by negative n. So when we multiply by negative n both sides as a power, we get this z to the power negative n equals to a to the negative n e to the I negative n. So now what we're looking for is this. So we make this subject of the formula just so that we come and replace it here. Making this subject of the formula, get z to the negative n over a to the power negative n. Now this is the same thing as 1 all over z to the power n. This is the same thing as 1 over a to the power n. So applying the index rules, this simply simplifies to a to the power n and z to the power n. So simply e to the negative I n theta is equals to a to the power n, z to the power n. So here we are going to replace with a to the power n, z to the power n. So here it's just some indices that we've applied. This is the same thing as 1 all over z to the power n divided by 1 all over a to the power n, which reciprocates to that. And let's replace, we replace here, we're replacing in z to the power n. Here, we're replacing in this. So this becomes mention z to the power n, a to the power n, which is this, over 2, n times this, which is a to the power n over z. Okay. Now, if you see properly, this is this is a geometric series. Okay, this is a geometric series. You can write it properly. You can factor out the halves, the 1 over 2, 1 over 2, and I will distribute the sigma before we distribute the sigma. So this can be written as this times this, same bases, powers you add. So a to the power n times a to the power n, powers you add. So it's just the same thing as 2n. We distribute 2 times that, 2zn. We can factor out a half here. You can raise everything to the power n here because we have n and n there. While factoring out 2. So we get here, we factor out half, which will be half, then we just remain with z to the power n. And here we factor out as well. We have a squared and z to the power n, they all have n, so we can factor out the n as well. Then with n to the power 2, z to the power 1. The idea is that we can multiply the powers. This will be 2 a to the power 2n, z to the power, a, which is now in the form of the general geometric series that we know. Right? So now here we can further find the sum of this. So now this is the sum to infinity. Now remember the formula for sum to infinity for geometric series is given by this. Sum to infinity of geometric series is 1 over 1 minus z, where z is whatever is raised to the power n there. So here the z will just be this z. Here, this z is just what is inside there. Right, so I assume you already know how to find sum to infinity, geometric series. All right, so but this is the formula for sum to infinity. So we replace the sum for this one, placing z there, this half, replacing this z, we put it here, the 1 minus z because it's just z here. Okay, then we have plus half. So this in our case is our z. So we are going to take the whole lot of this, we replace here, which is 1 over that to give us that. Here we can simplify finding the common denominator there. Find the common denominator there. So here to distribute, going to have this times this times this. Yes. Here first we find the common denominator there. We later distribute the 2 down. Right, so the common denominator will be that. To simplify, so this times this will give us this. This is how you simplify what is the denominator here. Then this 1 all over this is just the reciprocal of this, which will give us z all over z minus z, okay, like that. All right, so this is the sum. So now we can distribute, and we're distributing the two, have that. This is this will give us this. We'll distribute the two, then here we're going to find the common denominator. Find the common denominator. Just multiply this times this, then the common denominator give us that on top, and at the bottom give us that. So this times this, which is this, and this is this, which is this. We multiply the common denominator. When you expand everything to give you this, just the same way we used to find fractions in grade 12. Just like we used to find fractions in grade 12. So that is how you do that one, right? So yeah, and from here we can factor out the 2 on top, and at the bottom we see that there's a 2 everywhere. There's a 4 here, we can factor out the 2. So when we factor out the 2 on top, it will just be z, it will be negative s squared plus z minus z to the power 2. And here we factor out the 2, we're going to have 2z minus 2s squared minus 2az squared 2az squared. Right, then finally we can cancel out these 2, okay? And we're going to learn with that on the numerator. And by the way, we can add this and this, which will give us 2z. So adding this and this will give us 2z. And this will give us negative s squared z squared. Then on the numerator, we're going to have that. Just simplify. Now from here, we know what z is. Remember what we said, z is equal to a e to the I theta. This is what we said z is. So wherever there is z, we can replace this. So we're going to have that. So here it will be 2 times a e to the I theta because it's z minus s squared minus z, which is a e to the I theta, everything squared. Same applies here, it will be 2 a e to the I theta, where there is z, minus 2a squared, and minus 2z is e to the I theta, so it will be all of this squared, the 2 there, plus 2az will be that 2a squared, which is this squared, and that 2, then z is this, which we put. And now here, what we need to do here is we should factor out 2a e to the I theta. Now, why factoring out 2a e to the I theta? Let me just factor out, then I'll explain. So after factoring out 2a e to the I theta, on top, in the numerator, when we factor out 2a e to the I theta here, we're going to name it 1. Then here we just say a squared over 2a e to the I theta. Same applies here. There's this can be distributed as a squared and this squared, which is this, then divide by what we are factoring out. And the idea is that when you factor out, you can distribute this back. This times this, it will give us that. This times this, it will give us that. And that times that, it will give us that. So factoring out this on the numerator will give us that. Same thing on the denominator, we factor out 2a e to the I theta. Here we're going to remain with 1, so that we're going to remain with 1. Okay. Here we're going to remain with this divided by whatever we factored out, which is 2a squared divided by this. Same applies here, minus this divided by whatever we factored out, and this divided by whatever we factored. Right, so this is how you do it. So you factor out 2a e to the I theta. Now, why have we factored out 2a e to the I theta? Now, the idea is this. When we check out what we are trying to solve, we're trying to solve that so that this is equals to 1 minus a cos theta all over 1 minus what is it, 2a cos theta as a squared. When we check, the one is positive, and the number that we have positive here is this one. All these have negative, so we factor out the numbers that will give us a positive 1 here. So this will give us a positive 1 when we factor it out, which is this. Same applies here. This will give us a positive 1 out. Right, so now let's proceed. So from here, we see that we can cancel out this and that. Then what we are going to remain with, is 1 minus. So we can even simplify on top. So we see that this a will cancel with one of those. Here, this a will cancel with one of those. This e to the I theta will cancel with one of those. Same applies on the denominator. This 2 will cancel with the 2. A will cancel with one of those. Here, 2 will cancel with the 2. Now, here there are 2. This will be a squared and e to the I theta. So, which is this. So, we're going to say this cancel with one of those because they are similar. We see that a e to the I theta, then squared. Then here, 2 will cancel with the 2. Then a will cancel with this 1a. Then we're going to remain with 1a squared here. Then the e to the I theta cancel with the e to the I theta. And finally, on the numerator, we're going to remain with 1, then a over 2 e to the I theta minus, here again, we're going to remain with e to the I theta all over 2. Okay? That is on top. And at the bottom, we are going to remain with 1 minus, here we remain with 1a, which is a all over e to the I theta minus, here we remain with one of these, which is just a e to I theta, then plus a, and here we remain with just 1a squared like that. Okay. Now from here you see that you can bring this on top by introducing a negative, and bring this on top by introducing a negative, and we can factor out a negative on top. So we have 1, factor out the negative. This can be written as a e to the negative I theta all over 2. Then this will be plus in E I theta over 2. And at the bottom, same thing. We can factor out the negative here. It will be 1. We factor out the negative. This is negative I theta all over A, A, E negative I theta plus A, E, A theta and plus A squared, that is alone there. Is this A squared here. But remember, so we can start with the one that has a positive and the one that has a negative. And also remember that cos theta is equals to e to the I theta plus e to the negative I theta all over 2. So now, meaning that we were to rearrange this, so we start with the positive, but you can see that it is coming out. We start with the positive and the negative. The common denominator here is 2, so we're going to have 1 minus, in brackets, e to the I theta plus e negative I theta all over 2. Then we can factor out the a. We got an a here, there is an a right here. We got an a. So here you see we remained with one a. We got that a. We remained with one a. We out here. So there is this a. Okay. So we can factor out the a as well. It will be 1 minus a. We factor out the common a there. Then at the bottom, for us to have a 2 at the bottom here, we need to introduce a 2 here. So we have 1 minus 2. Then we can start with the positive part, which is this a e to the I theta plus e to the negative I theta is an a. After getting the a. And we say over 2. Remember there is no 2, so this 2 and this 2 can cancel out. So we've just introduced it. There is no 2, but we've not changed the equation because this 2 and that 2 can cancel out. Then plus a squared, which is there. Okay. So on top, you see this. So here we can also factor out the a. So when we factor out the a here, we factor out the a, what will remain is this. Okay. When we factor out the a, what will remain is that. So what is this? This is cos theta. So finally, 1 minus a here cos theta all over 1 minus this. This here is cos theta again, so which is 2a cos theta plus the square, hence shown. Hence shown. So this is how we show this one. So remember where we started. Started from here, then we went here. So that is how we show that one. So if you have any questions, have a good day.